Welcome back everyone. This is the next video on ImageJ and we will be talking about thresholding. Now thresholding is a selection of a region of interest based upon the colors of a particular image. In this video, we will be introducing you to the concept of thresholding. We'll also demonstrate a step-by-step process of application of thresholding tools in ImageJ, and we also will give you some examples of quantifying cellular features like the nucleus, cytoplasm, etc. using the process of threshold. So let's have the ImageJ toolbar here. So the very first thing you should observe is there are many toolbars sitting over here, and we are concentrating on the image tab this time. We'll be looking at the type of images, and we'll also look at adjusting and thresholding the image. So the things that you should remember is there are multiple sets of images over here. So you can see an 8-bit image, you can see a 16-bit image, 32-bit image, etc. Now the whole concept of bits is basically the concept of 1 and 0. Now 1 and 0 can be defined as black and white. So how many possible colors are here? We have only 2 possibilities. But in a 2-bit image, where a single image is represented by 2 numbers, so you can have 1 0, 0 0, 1 1, and 0 1. So there are 4 possibilities. This is a 2-bit image, and so on and so forth. So when you have 2 raised to 8, that is an 8-bit image, you can have how many possibilities? 256 possibilities. The possibilities are represented in an x-axis, which ranges from 0 to 255. The 255 represents the 8-bit that you see. And the number of particles in each single threshold is giving you a region of interest like this. Now, in this case, we have an image which is color in nature, and we will open that particular image and have a look at the threshold and the concept of colors that we use. So let's open the image, and we will open 2 files here. I have a scale file and I have a microscopic image file. Let's open the microscopic image file, and you can see that this is a histopathology imaging technique where you have a lot of cells which are stained by different entities. So let's take a small segment in this case. Let's take this small piece area here. But before we do that, we need to set the scale. So we open another file, scale. It may not be possible to usually keep the scale along with the specimen. Hence, we usually take a single image where you can see the millimeter scale set over here. So I will mark a known distance. In this case, let me mark 0.5. So here you have a 5 millimeter length. I'll go to analyze, set scale, and the known distance is 5 millimeter. This time I'll have to make sure that I have clicked global. Why? Because I need to use this scale in the next image. It's not in the same image. So once you click on global, you will be able to see the scale sitting in this particular image also. So let me first focus my region of interest. In this case, let me focus on these 4 cells, right? So I'm going to crop this particular image here. So I have a small section here, and I can go to different components that I can visualize here. So let me go to image and type. You'll see that there is an 8-bit image here. I would recommend you to go to an RGB stack. When you click on an RGB stack, you are basically coming in the red mode, the green mode, and the blue mode. So you have 3 modes that get separated over here. As you can see, the green seems to be the best color that you can see. Usually, green mode is the best way to appreciate a particular section because of the Bayes principle. So next, once we have this stack, we need to convert these stacks into a particular image. So we have stack, we have to convert it into image. So we click on stack to images, and you will be able to see that the blue gets separated, green gets separated, red gets separated. We are not interested in the red and the blue part. We'll retain the green part. Once you have the green part, we will go to the image adjust threshold. The keyboard shortcut is Control Shift T. As soon as you click on this, a small window opens. And in this window, you can appreciate this 0 to 255, which I had described in the beginning of the video. And you can see that predominantly the shades are sitting in this range, somewhere in the range of, let us say, 205 and 220. So you can adjust the threshold in such a way that you will be able to highlight the different cells within. So you can appreciate that the cells which are present over here, you are able to selectively threshold them. So once you do that, we can do that one by one also. Let's go one by one. So here I have highlighted the first cell. So I have a cell here. I will select this wand tracing tool here and click on the lower left corner. You can see that there's a yellow line that comes all around this. So once I have that, I will concentrate on the next cell. So let's have the next cell here. Let's say this is the next cell selection. I hold Shift button and click on the next. So you can see these two are selected. So the 3 cells in this particular case are selected. When I click on Analyze and Measure, I should be able to get the results are the same. So you're getting an area of 1.662 as the area of the cells. So 3 cells, 1.662. Now you can adjust the threshold further. You can use a polygon selection tool or a rectangle tool, select outside. And this time I am concentrating more on the nuclei. So here I have the nuclei highlighted. So I go to wand selection tool, select the first nuclei, hold the Shift button, select the second nuclei. Now I'm going to adjust for the third nucleus here, hold the Shift button, click on the third nuclei. So I have the 3 nuclei highlighted. I can go to Analyze, Measure, and I'll get the area of the nucleus. So 3 cells measure 1.662, 3 nucleus measure 0.031, and you can get a nuclear cytoplasmic ratio, etc. But what if you are interested in each individual nucleus or each individual cell? So we have another process called as the Analyze Particles. You can click on Analyze Particles and you have a set of units that come up. So we would like to specifically get a result where we will be able to display particle-wise results. So we can say, okay, in this case, we can even request them to show the outlines or the masks. And when you do this, you can kind of get the results in a different manner. Let me show you. So the old result disappears and the new result comes up. And you can see a small drawing which comes here. So you can see which are the number 1. This one will be number 1. This one will be number 2. This one will be number 3. So you have 3 nucleus present here. And 3 areas of individual nucleus can also be done. Similar things can be done for individual cells. And you can get the ratio and proportions also. So this is how we do a thresholding. And quick recap, we introduced you to the concept of thresholding and the bits of an image. We have shown you a demonstration of the analysis of the same in a cell and how you can use this to select and measure individual particles also. Please feel free to answer the MCQs that follow. Happy learning. Thank you.